You got 4 homeworks, same thing, and labs. Now, the first thing to do is be sure that I got it right. In other words, so many grades are going in that it's possible not to record them right and so forth. So check your tests, check your labs and homeworks. If I didn't get it right, just come up to me, bring the thing that's not there or wrong or whatever, and we'll correct it. At the bottom, you have a percent and a letter grade, which doesn't really happen in this course. This is called a credit, non-credit. So either you get a C or an NC. But the percent does tell you where you are. In other words, to get a C, actually pass this class, you have to have 70 or above. If you're below 70, that means you need to do some work. There's a test tomorrow, of course, that's test number 5. There's 2 more after that. And then there's a final, which counts as 2. So there's basically 4 more test grades. So a lot can be done in 4 test grades, and that's important to understand. Okay, so if you apply yourself, get some Math Learning Center help, you can change this quite a bit. But this is what's called a midterm grade. It's about halfway through. Okay, that's that. Now, I noticed that a lot of people have been absent this last week and the week before. I have to tell you, I'm going to stick with the 5 unexcused absences, and that's it. So a lot of people will be leaving us now. And I'll see you next semester, and that's the way it is. You can't do math here long distance. It doesn't work. It doesn't work. All right, so here's where we are. We're actually, our process is taking us to the end of Chapter 7. We're through with Chapter 7 now. We'll do the homework from last night, which is in 7.5, I think. Yeah, 7.5. And then what I'd like to do is go back and just review quickly the formulas for Chapter 6, the percent formulas, things of that nature. And just do a few example problems so that you can see really there's not much new in Chapter 6. There's only one formula to do. Is there a question?
Yeah. I thought, well, yesterday we learned 7.3, not 7.5.
No, 7.4 and 7.5.
That was the homework?
We have 4 and 5. Now we're going to
4 and 5.
So 7.4 yesterday.
Okay. All right. Let's go to 7.5 and see if you have homework questions. I'm sorry, 7.4. Yeah, let's go to 7.4.
It was 7.4 and 7.4.
Yesterday?
Yes.
Yes.
Okay.
It's at the bottom of the page.
Okay, number 83 says convert 0.01, and this is milligrams to micrograms. Okay, we're in the metric system. Certainly, on your cheat sheet, you should have a prefix there, and extend it out so that it gets to micrograms. What does that mean? It means micrograms are actually off the scale, so to speak. They're not on the standard prefix line. You've got to attach it. So here's the prefix line, which we've all memorized now. Okay, our basic unit here, which in this case is a gram, is in the very center. If you go to the left of center, you're at decagrams. That would be 10 grams. Then you go to hectograms, which would be 100 grams, and then kilograms, which is 1,000 grams. If you go to the right, then you're at deci, which is 1/10 of a gram, and then you're at centi, which is 1/100th of a gram, and then finally at milli, which is 1,000th of a gram. So going to the left, you multiply by 10, and you can start way over here. Still going to the left, you multiply by 10. But if you go to the right, you multiply by 1/10, or you're dividing by 10, in other words, same thing. All right, now the part that's missing on this is these two, which have no name, and that would be 1/10,000th of a gram and 1/100,000th of a gram, which nobody ever needs. And then finally, back over here, you get to the micrograms. And this is 1/1,000,000th of a gram. In other words, it takes 1,000,000 of these to make 1 gram. Okay? So in this case, we need that, because we're starting over here with 0.01 milligrams. That means our starting point is here, and we want to go to micrograms. So we want to go over here, and it goes 1, 2, 3 to the right, which means we take 0.01 and go 1, 2, 3. So we have to put another one in there, and that's going to give us 10 micrograms. 10 micrograms. Huh? And that's the nature of the prefix line. You're just hopscotching around left or right.
Where can we find this? Where can we find this?
Where do you find this?
Yeah, in the book.
It's everywhere in the book. Everywhere we have a metric system topic, yeah, the prefix line is everywhere. It's on page 437, it's on page 436, it's on page 435 and 434. And it keeps on going. And then the previous section has loads of it. And the way you remember it is these letters. Kids have donuts. This is called U for unit, until Dad calls Mom. The only thing is, that part is not on. Okay, that doesn't come with the memory stuff. You got to add that on. Okay. All right. Any others in 7.4?
Yeah. 69.
69. Okay, a bottle of water holds 710 milliliters. Okay, how many liters are in a 6-pack? All right, so we're talking about a 6-pack, which means we're going to have to look at 6 of these. And the question is, how many liters are in that 6-pack? All right, first of all, let's, a milliliter is 1,000th of a liter, right? Everyone agrees on that? It's this one right here, 1,000th of a liter. All right, but you've got 710 of them. If you had 1,000 milliliters, what would you have? Well, each one is 1,000th of a liter, but you've got 1,000, so you'd have a liter, right? Yeah. So having 710 of them means you've got the better part of a liter here. This is more than 2/3 of a liter. Okay, so that's rather large. All right, but we want a 6-pack. Okay. Well, that would mean every one of those members of the 6-pack would be 710 milliliters. And you keep adding those, you get 6 of those. That's repeated addition, that would be multiplication. Huh? So first of all, multiply 6 times 710 and figure out how many milliliters we've got. That would be one way to do it. Not the only way. So it turns out to be 4,260 milliliters. Okay, so we want to know how many liters that is. This is 60. Okay, well, we're starting with milliliters, which means we're here, and we want to go over here to liters. 1, 2, 3. This is the liters now instead of grams. Okay, so we go 3 to the left, which means we take this number and take its decimal point and move it 3 to the left. 1, 2, 3. That would be 4.26 liters in a 6-pack. Make sense? Okay. Any others? All right, let's go on to 7.5 then. Between U.S. customary and metric. Any questions?
39.
79?
39.
39. All right. It says a 2-pound box of sugar costs $3.19. A box that contains single-serving packets contains 354 grams and costs $1.49. Find the unit costs of dollars per ounce to determine the better buy. So we've got 2 situations. Situation number 1 is 2 pounds, and that costs $3.19. And situation number 2 is 354 grams, and that costs $1.49. Well, you can't compare pounds and grams. They're not only different units, but they're in different systems, so forget it. You know, that's really like apples and oranges. So we have to convert one to the other. And actually, it doesn't matter which one we do. We can go either way. We could convert 2 pounds to some number of grams. If we found that conversion factor in one of the tables, we should use it, right? And you are going to have the table tomorrow, right? Converting between these two systems. Just want to be sure. I know I've said it many times, but you know how people are. Selective hearing.
What is the test going to be covering?
What is?
From what to what?
It's going to cover from chapter 6 to chapter 7.
Okay.
Very simple. Yeah. Okay, we're on page 443. We have something that goes between pounds and grams. Well, that would be weight or mass. Well, we almost get there. We have 1 pound is 0.45 kilograms. Everyone see that on 443 in the table? Okay, so what the table tells us is 1 pound is 0.45 kilograms. And that's an approximate. Okay. All right, so we're going to have to use 2 conversion factors here, huh? We're going to start off with 2 pounds, multiply it by conversion factor number 1, which will get us to kilograms. And of course you want the pounds on the bottom, so you can cancel like that. And you want the kilograms on the top. So 1 pound, 0.45 kilograms. But then we need another conversion factor, because we don't want kilograms, we want grams. So we want to convert from kilograms, so put it down here, to grams. So these will cancel, and finally the whole thing will end up with some number of grams, this thing right here. So we're canceling units just like you cancel numerical factors. Okay, now, 1 kilogram is how much? It's metric system, it's very easy. 1,000 grams. Kilogram is 1,000 grams, right? All right, so what do we have here? We have a 2 multiplied by a 0.45 multiplied by a 1,000, and that should give us our number. This is 0.90, right? These two would be 0.90. Agreed? That's okay? 2 times 45 is 90, right? Okay. Multiplying by 1,000 moves the decimal point 3 to the right. Huh? 1, 2, 3. That's going to be 900 grams. Okay? So that's how much this thing contains. This, I'm sorry, this one. The 2 pounds of sugar contains 900 grams. All right, so we can now talk business here. This is 900 grams, and this is 354 grams. So now we get the price per gram. Now, all right, just think about that for a minute. Price would have to be on the top. Per is the division bar for a fraction, right? And grams would have to be on the bottom. So what we do is take that 319, that's the price of this 900 grams, divide by 900. This is dollars up here, and this would be grams on the bottom. And we figure out what that is on the calculator. Let's see. That turns out to be 4.00354, and then it keeps on doing 4s. So this would be dollars per gram, per 1 gram. Okay? Now, of course, dollars ends over here with cents. That's the hundredths position. So basically, it's to the penny, it's nothing. It's free. If you go over there to the tenth of a penny, then you start getting some digits coming up. All right, now we want to take this one, which would be $1.49, and divide it by 354 grams. And let's see what that gives us. And that gives us this number, 0.0042. And if you take them out to just that, this would be the thousandth, that's a 10,000. If you go out to the 10,000ths, that's what it is. There's a 0 after that, so that drops off. The 4 doesn't count either. So this stuff up here, which is the 2 pounds, is 35/10,000th per gram, 10,000ths of a dollar per gram. This is 42 10,000ths of a dollar per gram. So what's the best buy? Best buy is the one that costs the least, which is the 2 pounds. Now, why do you think that's true? Why is that the best buy? It's a bulk, right? 2 pound box.
Right.
It's a bulk box. What is this? This is a bunch of packets. Packets cost money to make, right? So that's why it costs more to get them in packets. Okay, any others in 7.5? 51. Okay, cough syrup comes in a bottle that contains 4 fluid ounces. How many milliliters is this? How many mLs? Okay, because it's between 2 systems, the prefix line's not going to help us at all. We have to go to the conversion table, which is page 443. And what we find is this. 1 fluid ounce is equal to 30 milliliters. Okay, that's what the table says. Now we're going to make that into a conversion. And here's how we do it. We start out with the number we've got, 4 fluid ounces, multiplied by a fraction, which will involve these numbers right here. We want to cancel the fluid ounces. We don't want them in the answer. So out it goes, like that. So we have to put the milliliters on the top. Okay, now put the numbers in. 1 fluid ounce, 30 milliliters. So we're changing this into a kind of fraction which actually only multiplies this by 1. Technically, it's multiplying by 1, so it's not changing anything. And we got 4 times 30, which is 120. That would be milliliters, so there's the answer. Just takes 1 conversion factor in that case. Anything else? 7.5. Okay, now the part that I wanted to take a little time to go over is in chapter 6. I'm sorry. That's 51.
7.5?
I think it is.
What page are you guys going, are you reading from?
Hang on. That was 52, I'm sorry. I did 52. So I'll just change it. There it is. Didn't get away with that. Right? Let's do 51. All right, a nurse gives a patient 45 cc's of saline solution. What's saline solution? Salt water, yes, that's it. That's all it is. 45 cc's of saline. How many fluid ounces does this represent? Okay, so we still want to go between metric and US customary. Now, the trick here is to remember that cc's are really mLs, right? As far as the prefix line goes, those are milliliters. So we want to go between milliliters and fluid ounces. Okay, so we go back, and actually we're using the same conversion factor. 1 fluid ounce is 30 milliliters. So we take our 45 milliliters, multiply it by the fraction, which has milliliters on the bottom and fluid ounces on the top. 1 fluid ounce, 30 milliliters. Out go the milliliters, and we're ending up with 45 over 30. And that will be fluid ounces. And we can reduce the fraction, huh? Both are divisible by 5. So 5 into that goes 9. 5 into that goes 6. And now we can reduce it by 3's. 3 over 2, which is 1.5 fluid ounces. 1.5 fluid ounces. Converted to a decimal. Any of them, 7.5. Okay, let's jump back to chapter 6. Now, first of all, I just want to be sure that you have a basic understanding of these percent formulas. When you first approach this topic, it can get to be a bit overwhelming, because what they do is take one formula and put different labels on it for different types of applications. And, okay, but that's, you know, then you end up with a whole list of formulas. But they're not different formulas, that's the whole thing. On page 374, I would highly recommend that you Xerox that page. And, or this section on the bottom, this table. I'll even write it up here, page 374. What they've got here is the following. An amount equals a rate times an original amount. Okay, now that's one way to put it. We put it in a different way when we started this whole chapter. We said amount is equal to a percent times a base. So already they're changing words on us, but it doesn't change the formula. The formula is the same no matter what the words say. The use of the formula is the same. Very simple use. And then they have all the different variations on it. Then you get stuff like this. Amount of sales tax is equal to tax rate times cost of merchandise. Amount of commission is commission rate times total sales. And then they go on to discount and markup, and even later they go down to percent increase, percent decrease. All of these things are just this formula. Now that's not to say that you shouldn't have this on your sheet. That's fine. You know, so you can recognize the different words that are used in different businesses and so forth. But they're the same formula. The use of it is exactly the same. So let's do some of these, and you'll see we're just using the same thing over and over again. Let's go, I'm going to chapter test, which is way back here at the end. I've chosen a few problems that I thought would give us a little exercise in using this formula. Okay, so let's simply do some basic percent equations and then go into the usage of it. So they do stuff like this. 40% of what number is 80? All right, now the point is we want to get this English sentence to look like this algebra formula. Okay, how do we do it? Well, certainly we can see the percent. There's the percent right there. It's got a flag on it, percent sign. Okay, that's multiplied by something called what number? Well, what's multiplied by percent here? The base. So therefore, this must be the base. Is, now that's an equal sign. In English, it's called is, or will be, or was, or whatever. And this has got to be the only other thing. And the only other thing is the amount. So this is your amount over here. Now, there are a couple ways of doing these. We started off with what's called the percent proportion. And the percent proportion looks like this. That a percent is equal to an amount over a base. But we wrote the percent as being, we dropped the percent sign and wrote it as being divided by 100. So the number of the percent divided by 100 is equal to the amount over the base. So before we even got into this English word stuff and changing the words and so forth, we did it very easily by using the percent proportion. Just set up the proportion. 40%, well, the P would be 40. It's the number of percent. So it's 40 over 100 is equal to the amount, but the amount is 80 over the base, and we don't know what the base is, so we call it B. It's that simple. I mean, it's just a simple proportion. There's only one way to solve them. You cross multiply. It's very easy. So cross multiply gives you 40 times B is equal to 100 times 80. And the way you get to the actual B is simply divide by what's multiplying it, in this case 40. Very simple operation, but you do it on both sides. This gives you 1B, that's what you're looking for. Now 40 goes into 80 twice, that gives you 200. So the base is 200. The mathematics is extremely simple. You can use this percent proportion, this thing right here, in all the various formulas. You just got to realize they're going to change the words on you. Percent is always going to be easy to see because it's got a percent sign. In the jargon, it's called a rate. Rates and percents are the same thing. So if we do an applied problem, they're just going to give us different words. Let's go down to here. Now let's do a commission kind of problem. Charles earns a salary of $400 per week. And gets a bonus of 6% commission on merchandise. Okay, if Charles sells $3,500 worth of merchandise, how much will he earn in that week? Okay, $3,500 is the amount of merchandise sold Okay. What kind of bonus? It says, no, how much will he earn in the week, not just the bonus. They also want this. This is a flat fee. This is sometimes called a flat fee or a retainer. A retainer just makes sure that he stays working for them, that's all. It retains him in the job. That's why they call it a retainer. All right. Well, in order to figure out the amount that you have to add to his $400 per week, you go back to this idea. Amount is equal to percent times base. Okay? You don't have to go through all the fancy words about commissions and commission rate and all that. It's not necessary. You're only using this one idea. Amounts percent times base. All right, so that means that the amount of commission is going to be equal to percent. Drop the percent sign, back it off 2 to the left, 0.06, times the base, 3,500. And that's it. You multiply those two things, and you've got the amount of bonus he makes. $210. Now they ask you, what is his total salary at the end of the week, so that has to be added to this. 400, his retainer, plus the 210, gives you $610 for that week. You can go through the fancy formulas, not necessary. All they're doing that for is so, if you go to a job down at Macy's and you want to figure out how much you're going to earn based on a commission kind of thing, you'll be able to read their words and relate it to the math. That's the only reason why they put that stuff in there. So you can relate to the real world, so to speak. Let's do some more. Okay, here's a good one. This has to do with sales tax. It says Brad bought a pair of blue jeans that cost $30. Not around here, he didn't. Okay. He wrote his check for $32.10. Cost of merchandise. Okay. He wrote his check for $32.10. This is total check. Okay, it says if Charles, what is the amount of sales tax that he paid? The amount of tax, huh? All right. Again, here's the amount over here, whether it's amount of candy in the mix or it's amount of tax, whatever, it's still the amount. It's equal to the percent times the base. All right, the amount, which is what we're looking for, we'll call it A for amount, is equal to the percent. Well, we've got to figure out what the percent is. How do we do that? Let's simply figure out the amount by doing a subtraction. 3210 minus 30 gives us 210. That's the amount of tax. And then they say, the next part of the question is this: what is the sales tax rate? Okay, now for that we go back here. The amount of tax we know is 210. The rate we're looking for, we'll call it just P, and multiply that by the base. What is it based on? It's based on the $30 that he spent. So again, to figure out what P is, divide by 30. That gives you 1P, and this is, of course, on the calculator, which would be 210 divided by 30. Boring, huh? 0.07. All right, now, this is where you have to be a little bit careful with these. When you're using this particular formula and you're solving for the percent, what you get is a decimal. Okay? But to convert that into an actual percent, you have to multiply by 100, then attach the percent sign. That's what you do to go from decimal to percent. So the actual percent is going to be 100 times that,
So it's
which simply
7,
moves it over 2 spaces
so it's 7%, right?
and then attach the percent sign. That's right, 7%. On the other hand, if you wanted to do this with this proportion, when you solve for P in the proportion, it will give you 7. You won't have to do any multiplying by 100 or anything like that. It actually gives you the number of the percent. So this, you're going to have to convert. This one, you do not convert. Okay. What else is there? Oh, there was one other thing, one other topic, and it had to do with interest. There are 2 types of interest. Let's take a look at that. The simple and compound. Excuse me. Simple interest. Very nice, easy formula to use. Interest, I, is equal to P times R times T. Where P is called the principal. R is called the rate, which means a percent. And T is equal to the amount of time for the loan or for the investment, either one. The other type of interest is called compound. And there's a fancy formula, and if you've got a scientific calculator, you can do it on that. Compound interest, and this doesn't give you the interest, it gives you the total amount in the account, which would be interest plus principal. This is I plus P. And it goes like this. You take the principal, multiply it by the following. It's going to be 1 plus. This is going to be the rate divided by n, all raised to the nt power. The n here is the number of interest periods in 1 year. Okay. And the P and the R and the T are the same. All right, those are the 2 formulas. So let's look at some examples and plug in numbers. Excuse me. Maury borrowed $5,000 at 8% simple interest. He plans to pay the loan back in 3 years. How much interest will he have to pay? And what is the total amount he has to pay back? $5,000, 8%, 3 years. So those are the 3 types of information we need. 5,000, 8%, 3 years. It's simple interest, so we use this formula. The interest he's going to have to pay back is the 5,000 multiplied by the rate, 0.08, times the time, 3, and that turns out to be $1,200. So the total amount he'll have to pay back, A, is going to be the interest plus the principal, which is the 1,200 added to the 5,000, or 6,200. Now, everyone has a a scientific calculator? Is that true? Anyone who does not have a scientific, buy one before tomorrow.
And they let you rent them out right over here at the lab, bro.
Oh, did it?
Yeah.
Oh, great, good. All right, let's look at a formula for that. Use this formula, which is the compound interest over there, to calculate the total amount in an account that began with $25,000. Here's your principal, $25,000, invested at 4.5%. That's the rate. Compounded quarterly. Now that means the number of compounding periods, if you're doing it quarterly, number of compounding periods in 1 year would be 4, right? Quarterly means 4. Okay, and this is for 5 years, t equals 5. Well, you know, it looks like a complicated formula, but really it's just plugging in numbers. Formulas are always plugging in numbers. So let's go ahead and do it. The amount is going to be equal to 5,000 times 1 plus R. Now the R is 4.5%. Again, drop the percent sign, back it off, 2 to the left, 0.045. Divide by n, which is 4, and raise that to the 4 times the number of years, 5. Now you can do this in a couple ways. You can actually make your calculator do all these calculations, but that's a fairly complicated bunch of instructions. So what I'd suggest is that you actually do that one and this one up here, you know, separately. And that it's not to make it easy on the calculator, it's to make sure you don't have to go through a whole bunch of buckets. So, all right, 0.045 divided by 4. So this is 5,000 times 1 plus 0.01125. And 4 times 5 is 20. Now you can go ahead and add those two also, that's easy enough, just decimals. So it's 1.01125 raised to the 20th power. Okay? Now that's not hard to enter into the calculator, that's fairly easy. Here are the button pushes. First of all, you do it like this, 5,000 of course, multiply, don't forget to multiply, because these two things are multiplied together. Open a set of parentheses, just like it shows you there, and put this number in, 1.01125. Close the set of parentheses. Now you're going to tell it to raise it to a power. Your key may look different, but here's one, x to the y. You may have a different power key. You have to know what your power key is.
I
That's
think you
another
got the wrong principal in there.
It's 25,000.
Oh, well, just put a 2 on it. That'll be nice. That'll give us some more. Okay. All right, you raise it to a power, and now you have to tell it what the power is, 20, and then equals. So these button pushings are not too bad. If you did all this calculating that we did by hand, you'd have a whole lot more parentheses and stuff like that. It just gets to be a pain. So it's just easier to calculate these things separately and then go to the formula. Now when you do that, for this particular problem, the result is $6,200. I'm sorry, no, I'm looking at the wrong formula. This turns out to be $31,268.76. So this factor right here, multiplied by the 25,000, gives you, what you have to pay back, or what they pay you. I guess it's an investment. Okay. So tomorrow we'll have our test. Don't forget to bring your homework, staples, name on the top, frizzy edges already cut off. Don't do that here. Don't use up test time with that. Do it before. And if you take it over for the services, you should go over there. And if you came in late, let me know. No.